So that's why you can fly a cruise missile right now into a window of a city when you fire the missile 2,000 miles offshore. You can't escape it. And unfortunately, it's killed a lot of people. Anyway, just a side bit there. Wake you up. Anybody fall asleep? Okay, sorry, go ahead.
All right, so a couple of questions on the project. So, what would you consider to be like typical uses of this system? How would this system use for?
Yeah, so that's a good question. The typical use is, let's say that I'm gonna give two examples. Let's say that I'm running a utility, like Paso Electric. And I get all these sensors down here, and it's connected to all my electric grid down here. This is my electric grid that supplies electric current and voltage to your homes, to your laptops, to your Monday night HDTVs, for Monday night football, and all the power. And number one, I'm the utility. I want to make sure that everything's working. If I have an outage, if a transformer goes out here at the Schuster substation, like it did at UTEP about a month ago, we lost power on Monday and Tuesday, then I want to know about it right away. The way El Paso Electric does this right now is usually by telephone calls from the customers. So the customers get a call, hey, my power's out, they start getting 50 calls, and then they locate the outage. They have some automation for outage management, but you want to be able to do this on a millisecond basis. To get the sensor information from here, up in here, get it stored, and you get it visualized, an alarm comes up here in the operations center and tells an operator, hey, there's an outage at Cielo Vista Mall. Better fix it, or otherwise a lot of people catch shock and they're going to be very upset. So it's for visualizing critical infrastructure, monitoring, management, and controlling critical infrastructure. Okay. Another example is, let's say I'm FedEx, and I want to know where all my planes are, where they are in the air, where they are in the ground, what's happening with the shipments that are going on those planes. And I want to be able to visualize when a problem occurs. Let's say a 747 has some problems on the ground and it has to be fixed for about 3 or 4 hours, so that plane's out, they're going to be able to make its delivery schedule. I want to be able to visualize that up there and take corrective action. So my FedEx Enterprise, my company, still keeps running. I'm able to eventually deliver those goods on an alternate route. I might want to call UPS and say, hey, UPS, can you pick up my goods because my plane's down? Those kinds of things. So that's an example where you want to visualize a large network of assets, airplanes, electric power grids, water utilities, okay, down here, gas pipelines, the operation of the Western Refinery that's on the east side of town. That's an example where you want to visualize its operation and figure out when something happens, if there's a corrective measure you have to take. Another thing too is that you collect all this data, you have it stored in here, and you can go back and do analytics, like forecasting, for instance. You do electric power forecasting based on weather models, usage, consumption, or you can do forecasting for FedEx based on the operations of the airplanes. Any backups you may have of any alternative routes. So you want to have analytics, data, the processing, and then the visualization. That's kind of two examples.
So in terms of those alerts, would you rather have a final report? Would you rather have individual events and let you know, oh, something's happening right now?
Yeah.
Or what would you rather have?
Okay, I think for these types of systems where critical infrastructure is involved, you have to have instantaneous. And I always call it near real time, because sometimes, what does real time mean? Does it mean a millisecond, a microsecond, or a nanosecond? Well, to humans, that doesn't mean much because it's so fast. But if it means a difference between a microsecond transfer from here to there, you get an instantaneous alert. If the network's not very good and your software collection is not very good, your storage is not very good, it might take 10 minutes. That's no good. Okay, so you want to have a near real-time alerts.
What would be a good estimate for that? What would you like to see on this system, a good timing?
Yeah, for a system that we're going to look at, I'm going to talk more about the system that you should be looking at in 3 areas. Is we're probably looking at seconds type response. Now that's important because, in your software requirement specifications, there's always a section that has to do with performance, right? And performance and sizing, and so there's pieces of the specification that describe the functional processing. There's algorithms, there's data analytics, there's operational requirements or operational specifications that describe the day-to-day operation of the system, or the minute-by-minute operation. And then there's performance requirements or performance specifications. So a performance spec may be that the system has to visualize an alert in less than 2 seconds. So an alert here would be described by the scenario where you have a critical event happening here. You monitor it, you pick it up, send it to the network, and then display it in less than 2 seconds. Now, in some other applications, you might have this requirement be 0.2 seconds. See, so the way you design a system, you can't have a lot of pork and fat in here in the enterprise service bus or the system implementation, because it has to run fast. It has to acquire the data quickly, transfer it to the network, get it up to the storage, analyze it, and display it.
Can you give us a couple of examples of those alerts? Surrounding things that we will be looking at?
Yeah, so, I think in your case, limiting the problem, to the UTEP campus. Let's say this is a UTEP campus. So these are smart meters. Right? And here are the buildings. You're measuring consumption on that building. We have a smart meter right now in the library, and it measures the energy consumption, the amount of amps and volts, the kilowatt hours that's used every 15 minutes. We poll that meter every 15 minutes and collect data on it. Another example would be here where this is let's say these are solar photovoltaic systems. We have 2 of them on campus. One is at the rooftop of the swim center on Sunbolt. And the other one's in the facility services near the police department. There's a canopy in the parking lot that has, so there's 2 different systems. One alert would be when a solar PV panel is malfunctioning. If it's malfunctioning, then if it's in series with all the rest of the panels, then you may have an outage. So this panel is not producing DC energy, it's not getting converted to AC energy, and the power that it's providing to the building here is not available. So that's an alert. The smart meter may be when something happens in the library and say a transformer drops inside the building of the library and the electricity goes out from that building, then you'll get that alert back into the visualization part.
'Right, so in terms of the actual application, do you anticipate these to be accessed through a web application, a web service, a mobile application, or how should the system be accessed?
Okay, good, that's a good question. What, people that run these operation centers or are responsible for this infrastructure, and I'm just gonna call this an ops center, you know, just for names. They want to know what's happening in every sector that's being monitored. So they want the alert to come up in the operation center, which would be the computer room display with wall displays. They want to be able to access the status of this through a web interface. Okay. And they also want to receive an alert, a text on their mobile phones. So all three. And you can design it all three because these guys, these URLs are all based on the web services. The mobile phones have apps that are based on web services that gives you these either internet or text messaging, SMS messaging to your mobile. So, and this is a different kind of interface, but they all use a similar interface to transfer the data. All three.
Right. So now that you mentioned, instead of, in terms of users, who are gonna be the users to this system?
Okay, so I think you have multiple users here. If you just look at the daily operation of the system, there's people here that maintain these buildings and these sensors. So that's like the electricians, the heating, ventilation and air conditioning people are all down here. There's an IT department that takes care of all this software, the software buses. There's probably a database manager that takes care of that. There's probably another IT person that's responsible only for the algorithms, for the functional processing that the center does. And then there's visualization GUI engineers that deal with these displays and that data that comes in and out of the visualization center. So there's multiple, these are what are called actors, right? In the UML sense, these are actors that contribute or that receive something of value from the system. And they're at multiple levels in the system. So I think you need to consider all of these as being users.
What about is this gonna be open to the public somehow, or is this going to be something internal?
Yeah, you know, that's a good question. For instance, now you have to start talking about, thinking about cybersecurity features, right? What features are you going to allow? For instance, this solar panel has what's called in here an inverter. The inverter takes a DC energy from the solar panels, converts it into AC. Sorry, that should be down here. And it transfers the AC energy to the building, or to the electrical power. That inverter has an IP address. You probably don't want that IP address publishable to the internet because somebody will come in there and turn it on. Or they'll operate it in a mode where that might destroy the inverter. And so I think you have to be cognizant of where there's IP addresses in this equipment and protect those IP addresses, either through the network or through devices that you might put here that would be called cyber security appliances that you put in there right before it hits the IP address. Okay, so when you say is